This is a boring head. When paired with a milling machine, it can make very accurate holes in a very wide range of sizes or put you to sleep with pointless conversation. And they work great, even these import ones. However, the eccentric and unbalanced nature of these tools tend to work best with the big, heavy professional machines they were initially designed for. So in this video I want to redesign and remake from scratch my own boring head, optimizing its feature to work best with the lightweight, crappy mini mills we hobbyists get to play with these days. Three things in particular. First, I'd like to get back some precious real estate on the Z-axis. These things are huge, and even if having a large tool is an established device of popularity, it doesn't do much good if you have a teeny tiny machine. I also would like this thing not to push the head of my machine out of square as it rotates, so as the tool holder moves in this direction, I want a counterweight to move at the same time in the opposite direction to balance things out. And since we're here, I'd say we squeeze in some fancy and make it toolless, because fiddling with 37 different Allen keys to set every cut is about as fun as brushing your teeth rectally. So we'll put a flourishing of knobs all around and see how it goes. Alright, I feel like I'm setting myself out to bite a little more than I can chew, but don't worry, every time I do something stupid, I'll say, after all, it's just a prototype, and we'll pretend everything's fine. I'm designing the whole thing around this 35 by 35 millimeters cold roll I have in-house. After all, it's just a prototype. That being said, I'd still like to produce somewhat accurate work, so I started by tramming the mill, which is a pain, but also a good habit to have when the head of your mill is prone to swivel at the whip of a fart. God damn. When I can, I like to start every part from the feature I'm most likely to screw up, which doesn't necessarily imply a threaded hole. In fact, in this case, it's the very precise locating bore that will center the shank of the boring head. I flattened the drill hole with an end mill before boring so that I can leave enough clearance to avoid the screaming of 10,000 souls every time the boring bar touches the bottom. While the reason I'm desperately fiddling with a micrometer is that one of the bolts of the vise was loose, shifting the position of the bore. Quite the disappointment after I went all anal about ramming the mill, but eventually I managed to get everything back in the center and even on tolerance. What can I say? Better be lucky than competent. After that, there's just some plain drilling and tapping, so to spice things up, I decided to power tap those blind holes. And it was fine, totally fine. Same thing for the hole on the sides that will hold in place the plates to close the sides of the head. Then it was time to get serious and start removing a considerable amount of steel. Gotta carve out the channel for the lady screw. The most keen-eyed of you may have noticed I'm using coolant for this project, despite all my best intention of using only oil to prevent rust. But oil leads to a terrible mess. A terrible mess leads to cutting dry. And cutting dry leads to short tool life and abysmal surface finish, while coolant leads to this smooth marvel. I'm never going back, coolant is the best, let it flow, let it flow. So yeah, if I can get the surface finish with a $3 end mill that lasts for the whole project, I don't care if the mill grows a few spots of rust. But let's not get too distracted. Once the channel for the lead screw is done, we can cut the main dovetail of the boring head, to which the sliders will be fitted later on. This dovetail will also need to clamp down on the sliders to lock everything up. The classic approach would be to use a gib and some set screws, but I'd like to spice things up and make a flexure clamp. So I start by drilling and tapping an M8 thread, then I clear the upper part of the threads, crystal clear, and set the slitting saw to cut the dovetail between the threads and the clearance so that I should be able to pull the dovetail close with a single screw and lock everything up. Hopefully. I don't know what happened, but that cut was a lot higher than it should have been, which means I was about to slice the part through. Great. So I made some executive changes on the fly, which is always a great idea, and eyeballed a less efficient clamping profile. I still get about 20 microns of clamping movement when cranking on the knob, which is not a lot, but if the sliders are tight enough, it could do. By the way, if you're wondering why you didn't see me make the knob and the shank, it's because PCBWay did them for me along with sponsoring this video. As you should know by now, PCBWay doesn't just make PCBs, they also support the rapid production of prototypes with 5-axis CNC machining, laser cutting and metal carpentry, EDM wire cut and 3D printing freaking metal. To use the services, you just go on their website, send them your models, get your quotation through the website, place your order and get updates on the production status until your parts arrive quickly and in a vacuum sealed bag. Check their Christmas offer at the link down below and ho ho ho. I finished the body with a few flamboyant chamfer that will pair nicely with the shank and a couple of regular chamfer on the bottom because everything's better with chamfers. Now, for the two sliders. There will be a lot of steel to turn into chips to make these two, so I'm taking out the big guns and prepare for war. I'm also going to grab a respirator because those cute puffs of mist told me my mistless spitter wasn't properly dialed for coolant. But even if it was, when the coolant hits the end mill rotating at high speed, I'm pretty sure it gets atomized thin enough to tickle the throat. So for intense milling, wearing a respirator is probably always a good idea, possibly with the right filters. By the way, to rough and finish this whole operation, I'm using a free flute $3 6mm carbide end mill, which with the coolant rips through the steel fast and clean while costing basically nothing. Once the post for the lead screw is to size, I can keep milling down, easing the way for the dovetail cut that shortly follows. This is a critical operation because I'll need a very tight fit, and I'm not all that comfortable with dovetail cutters. So while I was sitting there, you can believe I was trying very hard not to let loose some stool on the stool, with only marginal success. But by the end, it was totally worth it. Off camera, I machined the counterweight on the other side, which is exactly the same, aside from the fact that I forgot how to rate the DRO and completely messed the dovetail, which consequently led to kicking this part for half an hour around the shop, which you can see in the great surface finish left behind by the concrete. However, before remaking this part, there is a teeny tiny problem to address that can scrap the whole project. You see, these pieces, once inside the body, are supposed to move away from each other. And in my head it was pretty simple. Right thread, left thread, a piece of old threads in the middle, and as it turns, one will go in one direction, the other in the opposite. Except right threaded holes only ride right threaded screws, and left threaded holes only ride left-handed screws, and I kinda forgot that, which is not very good for a project. Except when I started this project, I didn't have a lathe, so this would have been an unsurmountable problem, but I do now. It's right there. However, despite being right there, the lathe in question was so far out of level to be unusable, and on top of that, it didn't have any visible way to level it. Secret Feet, huh? That's a good porn title. Okay, too bad a straight hole is pretty useless. Nope. Nope. The things you do for a bolt on a Sunday. Finally I can level this thing. Right, level this thing. I won't waste your time around my genius plan of setting the lathe around the ground shaft that turned out to be a banana, or the time I spent doing a test bar with the only stock I had at hand, which was way too thin and flexible to give any meaningful result. And please, don't let me start with the level. This is all I got, alright? It's... I was going to 3D print a precision level, or at least a very sensitive level, but I broke the capsule during testing, so I'm using this. And this is not... It's like getting a prostate exam with an I-beam. Painful and not very accurate, so I played like a carpenter level roulette, and I got the error cut in half. For hundreds of a millimeter over this distance. It's not good, it's bad, it's... However, I'm not trying to set the lathe perfectly now. I'm just trying to set the lathe decent enough to try to cut a screw. So, let's just take this beautiful piece of high-speed steel I inherited with the lathe, and with inherited I mean paid for, and make a threading tool, right? Yeah. I've never ground tooling for the lathe before, but I've done plenty of blades back in the days, so I'll do it my way on the belt grinder. On paper it's simple, right? On the top view the tool is ground at 60-degree point to cut the threads, and on the side it needs clearance to give this edge a cutting chance. The table of my grinder can't be angled per se, but I can stack a bunch of washers under the top screw to get my clearance angle. And I can rig up a guide for the main threading angle. I'm removing the bulk of the material with a 36 grit ceramic belt that eats the high-speed steel away like its mama made it. And then I step up to a 60 grit and then jump to a 600 to polish the edge. Edgy. I'll go out on a limb and say this radius on the point ain't gonna work. That's right, motherfucker! Like many other enticing tales, this one too starts with a quite impressive shaft. Stainless steel nonetheless. It's only 6mm wide but pretty long, so we're gonna center drilling it and docking it with the tailstock before marking the center and turn the clearance point where the two opposite threads will meet. And hey, where's the chuck key? Ah! Why I can't find anything never? Tool rack for the lathe, like right there, like right there, here. I want it here. I want... There we go. Now I just need a way to put a collet on this thing. A junky setup goes in the lathe, in the lathe, in the lathe. I'm forcing this thing on because I want to see if it gets looser going down. Well, I'm very pleased. You know, a lot more pleased with this first time than another one that comes to mind, but yeah. I can see why people love and hate single point threading, because it is cool, but man, it gets unnerving fast. Here, the threads were coming out fatter in the center due to an excess of deflection and sugar, so I marked out the problematic sections and improvised some human eyeball control machining during the cut to compensate the differences. And what do you know? It actually worked. Yeehaw, baby! I did it! Look at that! It's a screw. Right threaded here, left threaded here. These will intersect, so you turn the screw and they drift apart. Sadly, this means I get to remake this part that I've... What I have here looks like a piece of high-speed steel, but it's actually a metallized middle finger of an ancient machinist. A secret relic that at the right time of the year... La 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 la. Okay, enough fooling around. To drive this project home, I first need to put this back on the milling machine and make this groove deeper, because apparently I don't know how to read my own drawings. If you'll ever find yourself with belly trouble and a long flight ahead, try to put back on the mill a part you thought it was finished. It will keep all your sphincters airtight for days. Guaranteed. Once that was done, I just wanted to blaze through the remaining holes and cosmetic work as fast as possible to finally put this thing together and see if it was going to work or not. And this is why you don't try something new when you're about to finish a complex part. Nice. I tried to reclamp the part vertically, but the flutes weren't long enough. So I carefully clamped the dovetail, and following the words of the immortal poet 50 Cent, I went about the cast just a little bit at a time. And the part is still alive. Not too shabby. Counterweight on the butcher's block. Almost there. I cannot express clearly enough how much I hate this operation. And there you go. Once again, luck rescues me from incompetence. Okay, last thing to make are these plates that close the side of the head and these locking knobs that tension the lead screw and hold everything together. To make the plates, I squared a full chunk to size, then I cut off both ends and finished off the sewed face to final thickness. After some delightful lathe work, I'm milling out the pocket for the head of the screw. Tapping, cutting, clearing, and milling down the relief to give the M4 screw a fighting chance in deforming this thing to actually clamp and lock. And now it's finally time to see how it goes all together. I indicated the sliders in the center of rotation, then tightened down and locked the side nuts. Let's see if it works. I took a first cut and measured it as a reference. Then I set the head to cut 20 microns on the diameter. And okay, it should read 13.11, here it goes, nothing. 13.6. 50 microns of difference between expectations and reality in machining is the equivalent to a difference of 5 inches between expectations and reality in other departments of life. It's a bloody big difference. So I went along and made a few more cutting tests. Lots and lots of cutting tests, actually. And I'm sorry to say that this thing is all over the place. Sometimes it's spot on, but more often than not it's off by between 50 microns and 1/10 of a millimeter on the diameter, which makes it a good kitchen tool for boring donuts, but not much more. If the error was due to run out, it would be a constant error. The fact that it comes and goes makes me think it's a problem of rigidity. And by looking at it in hindsight, the bar has a very shallow engagement and the dovetail is a plodding spring with just one screw. What was I thinking? Same thing with the anemic lead screw plus a million different things. But it does stay balanced when it's all open and it's handy to set and takes a lot less Z-space than the other one. So I stand by the intent and blame the bad design. I think I will revisit this project one day with better chops, better steel, better design, maybe even better tooling, and make my cool boring head for crappy milling machines. I'm sorry if the project has been a disappointment, but after all, it was just a prototype.